Okay, this is a really lovely projectiles question. So it's fired out with some sort of initial velocity u at some sort of angle theta. It's going to form a trajectory which is going to look something like this. Start out in that line, gradually start shifting down, and at some point when we're going to look at it down here, we know that it is travelling at 12 meters per second, and it is travelling at 30 degrees below the horizontal. So that angle there is going to be 30 degrees. So the first thing I'm going to want to do is decompose that into a horizontal and a vertical vector. So my vertical vector is going to be 12 sine 30. So it's going to be 12 sine 30, which is 6. But actually it's downwards, so we should really make it negative. So it's going to be minus 6 meters per second. And my horizontal vector here is going to be 12 cos 30, which is 12 root 3 over 2, which is 6 root 3. So at this moment in time, when t equals 3 seconds, it's going to be travelling to the right at 6 root 3 meters per second and downwards at 6 meters per second. Now, one of the things that people commonly forget on projectile questions is that this vertical component is going to vary with time because acceleration acts on the particle vertically. However, this horizontal component, this 6 root 3 meters per second with which it's moving to the right, does not change. In a model, there is no acceleration in the horizontal direction, which means that the speed there remains, the velocity, the horizontal velocity, is going to remain 6 root 3 meters per second. So, we know that we've got a particle travelling horizontally at 6 root 3 meters per second. It's got some sort of vertical component, which is x, and we know that its speed has got to be less than 12 meters per second. So this has got to be less than 12. So I can use Pythagoras to work out what x is. So I'm going to do 12 squared, take away 6 root 3. Just be careful here on your calculator, squared, and square root it. And you should see that on my calculator I get an answer of 6 meters per second. Well, that shouldn't surprise us if we have a look at what's happening in the question. At this point here, we know the vertical component is 6 meters per second and is travelling at 6 root 3 horizontally. That gives an overall speed of 12 meters per second. So if I wanted to be travelling at less than 12 meters per second, and this is always constant, I know that the vertical component of the velocity has got to be somewhere between going upwards at 6 meters per second and downwards at 6 meters per second. I know when the time is 3 seconds, it's going downwards at 6 meters per second. So now the question is going to be, is when is it going upwards at 6 meters per second? If I can know those two times between them, I know that the vertical component is going to be less than 6, and therefore I know that the overall speed is going to be less than 12. So let's try and do that. We're going to resolve vertically. Now, I've got some vertical component. S I'm not interested in. U is what we're trying to find out. Now, at time 3 equiseconds, I know that the velocity is minus 6. And I know that the acceleration is minus 9.8. So I can now use v equals u plus at to find out what u is. So minus 6 equals u minus 9.8 times 3. That tells me that the vertical component of u, so u vertically, is equal to 23.4 meters per second. So I know that after 3 seconds the velocity is downwards by 6 meters per second minus 6. What I'm now going to try and do is find out when it's positive 6. So again, using Suvat, I've got S I'm not interested in, U equals 23.4, which I've just worked out, A of V equals positive 6, A equals minus 9.8, and T is what I'm going to work out. So I've got V equals U plus AT again, and I've got 6 equals 23.4 minus 9.8 T, and we're going to rearrange that, and we should get an answer of T equals 1.78. So determine the time for which the particle has a speed less than 12 meters per second. Well, the answer is going to be from 1.78 s to 3s, and if we actually want the length of time, it's going to be for 1.22 seconds.